The final two selections on the cut point palette are offset patterns, and I'll look at pattern point and offset group in this video. In this video, I'll try to explain pattern point. Pattern point is quite interesting, and there's only one example in the example files provided with Cornlathe. But I'll try to show you what's going on. So I'm going to open my pattern point file here, and I'll do butterfly, which is the one that Bill provides in his program. So I have to change the view here, and you can see, gee, I like that. Isn't that fun? Turn off the grid so you can see it. Zoom in, render that, and you see, turn off the lines, you see, oh, that's really nice. I like that. And you can see where it is. It's offset to the side of this particular curve. There's 3 repetitions. It all makes sense. So you go to Cut Rosette, and you might speed these up as I've done for my own setup, and you say write G-code. So you write it for all points, and you look at that. So here's the one we just did, 0 kilobytes. What's wrong there? So I edit that with Notepad++. There's nothing there. So that didn't work. So you delete that one, scratch your head a little bit, so you go back to write G-code, and there's one that says 0. Filter output for offset point, 0. So no offset. You write that, and you go look at that file. Here it is here, and it's 5 kilobytes, so that's promising. So let's look at that with Notepad++. So here are the coordinates, X, Z, and C, which I typically will do a search replace, and I'll replace all the C with A. So let's do that. Close that. So there's your rotary A axis. Ordinarily I would save this as something else so I didn't overwrite it. So I'll do that. I'll say C to A and save it that way. So let's look at this G-code. So this is the A axis. Starts at 0 and it goes through and it turns at 360 degrees. And then it goes back to 0, starts at A, turns at 360 degrees. And it's offset as it's supposed to be. And what you'll see is all these numbers are the same for each iteration. 360 degrees. So what's going on? And what's going on is pattern point cuts around the axis of rotation. In other words, let's put the lines there. It cuts this, but the axis of rotation is right here. So you have to be able to move your workpiece so that it rotates all the way around this single point. Otherwise, it'll just keep cutting in the same place. And that's the catch with pattern point. The next problem is creating pattern points. That little butterfly pattern, if you look at it, and we'll go up here to the view, how can you cut that with a fly cutter? That's really quite interesting. So we need a window. I think that's the one I want. So there's butterfly. That's the pattern that's cut. And you look at that and you think that's very confusing. How does that work? And it took me a long time to figure it out. And there's only the one to go by. in Cornlathe. But eventually I did figure it out, and I made a number of different pattern points. So I'll go to the end here. I made a maple leaf, I made a shamrock, a moth, a petal round thing. I guess I should have this up so you can see. We'll change this. So I'll go back to here, maybe the cut points, so you can see what I've done. So there's the maple leaf. That cuts out not too bad. When it's rendered, I'll turn the lines off and you can see that that cuts a pretty good maple. These didn't just happen. This took quite some thinking. So there's a shamrock. I'll turn the lines on, get my rendering going. So that's a pretty good shamrock, I think. And let's try another one I have here. This 5-petal round that you see here. So I will get that one going, turn on the lines so you can see, turn the lines off, and there's kind of a little 5-petal round flower. Using the dome chuck I can position these, and that's what you were seeing me cut. I'll do one more. I was trying to get a shell pattern, and I'm not so sure I did a very good job, but that's what I was trying to do anyway. Get a shell pattern out of that. So that's a work in progress, because I don't think that one worked out very well, but that's sort of the problems with doing this particular design. So I'm not going to get too much into how to make these designs on this particular video. I'll do that on another video, but you can start a new pattern. It needs a unique name here, and you have to figure out a way of clicking on the points. And double clicking puts in a point. And as you play around with it, if you select your new pattern here and over here in your data navigator, then you can see how your alterations are coming. So that's the 5-petal round. I also did a 5-petal sharp if you want to see that one. Like that. That looks pretty good. And that was pretty simple to do that. So, click, 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 click. And then that's as far as you have to go, just halfway. And then you can mirror left and right. And if you normalize it, sometimes you want to do that, sometimes you don't. It'll stretch it out to fill the whole thing. But I was happy with this particular pattern just as it was. And it takes a lot of trial and error to get these to work just right. But in another video, I'll show you a solution I came up with that was relatively easy. So that's pattern point to this point. I will say that when you create a new pattern, it goes to the design that you save. So if I create a new pattern, I'll open up my template, or when I got started, I would take something like butterfly, which is where the only pattern was, and I would duplicate it, so highlight it, and you say copy, and then up here you have to say paste, and then you get a butterfly copy here, and I would rename that to, say, pattern point tests, if I could spell, just for example. And then every time I wanted to make another pattern, I would open this file. I wouldn't do it the usual way of right-clicking and going through templates and things like that. I wouldn't do that. I would just open this file. I would duplicate it first, open the duplicate, or open this one so I didn't lose it, make my new template and save it to this when I was done playing in here. That's how you get your work to get saved. Otherwise, if you look through some of the other examples, see the Cornlathe examples, you'll look through cobblestone, for instance, view it, you'll look at the cut points. For instance, that's the end-sided one. If you look through these cut points, you won't see butterfly here. It's not there. And where it is in that butterfly thing. In favorites, it's when you first get your program up and running, butterfly is only in butterfly. So I've cleverly managed to get the windows to all changed to where I don't want them. But that's the original sort of pattern that we had before. And that's the only place you're going to see it. I'm going to go back to the properties one, see if I can find what I want. Oh well, it's all disappeared. At any rate, you have to look at where the cut points are. And that's how you do that. So this is a dome chuck that I built. And this allows me to turn a workpiece on its axis wherever I want it. So my chuck goes on here. I'll show you with the parts. I put a chuck threaded onto this bolt. The bolt goes through the thimble, and the thimble goes in this carrier, and the carrier goes in here. There's the thimble. I actually used Cornlathe to sort out the pierce point patterns there. There's the assembly. So my chuck would go on here with a bolt through this hole. And here it is in action. You can see I've made some other attempts around the side of this little test piece. And the whole bowl is turning around an axis that's actually quite close to the bottom part of the bowl curve. Using a fly cutter like this one, not all patterns are suitable for turning into the side of the bowl. And you have to get the index point, or the height of the cutter exactly right, or you get pinwheeling like you saw on those ones. Right here and right here, where I'm off center with my cutter there. But otherwise, Cornlathe will cut that pattern for me and leave a fairly good result. Now this wood is terrible once again. This is plain aspen poplar that's as dry as toast, but it gives you the idea of what a dome chuck can do. The way I use pattern point to apply these to one of my pieces is mainly for planning. Since my setup is not automated with the dome chuck, I have to move it this way. And by using the software to decide how many repeats of the pattern I want. I can see what I will get. So the information to move things is actually included in the program. This one right here, distance to the top, right there, right now it says 1.01. So that's from the very top. While you're turning your piece, if you leave a dot right in the center, then you have your reference line that you can measure down to the center of the pattern. If you change this pink group to there, for instance, and go back to your data navigator, you'll see that that distance to the top is changed to 0.73, so about 3/4 of an inch. And likewise, if I move it all the way down, say to here, that moves everybody, and the distance to the top is 1.6, so I can measure simply from there to there, put a dot, and then bring in my tailstock and line it up on the side of the piece. I might do that on the lathe, even measure down while I'm turning the piece, measure down to where I want them, and then just put a line so I can measure up my tailstock to point right at that line, and then the pattern will cut where I want it to cut. And the other important thing that Cornlathe can do is this optimize button down here. You'll see the pattern gets slightly bigger in this case, and it also conforms to the surface. It curves to the surface, and that takes into account distortions that would happen as you're trying to cut. So as well as it can, the program will compensate for the surface curve of your piece and try to apply your pattern point pattern correctly to the surface. Well, now you say, I understand how to position the butterflies, and I understand that the rotational axis has to be here, so I need some kind of a dome chuck so I can manipulate the piece to get it there. And with the dome chuck that was illustrated, there's a way of indexing around to the next one. That's fine. How do I do the G-code? So you go to the G-code window, you move those over, you click Write G-code, as I've shown in other videos, and here it is here. I'll open that up in Notepad++, and here's the 3 different sections that are essentially the same. So there's a couple of ways you could deal with the G-code here. This part up here where all the C's have been replaced with A's, that doesn't matter because of the semicolon, they're all commented out. What matters is this block. So you could save this program and run it as it is, and you would have to pause it after the first cut when it got down to here, and then pause it after the second cut. And each time you paused it, you would have to reposition to the next spot where the pattern is supposed to cut, if they're at 120 degrees or 90 degrees, whatever it is, on your dome chuck. Or you could select that, scroll down with your wheel, hold the shift key down, and just delete all of that. So you just have one instance, and save that. I'll get rid of that extra line. This is what it's running. You just run it 3 times. So you save this, position your piece where it's supposed to be, run this program. When it's done, it'll pull away. So you reposition the piece where the next pattern is supposed to go, restart the program, and so on. That's the easiest way to do this, and what I typically do for this, and also for offset group, which is the next offset pattern I'm going to be discussing. The final type of offset pattern and the final type of cut point off the palette here is offset group. So I'm going to create a new piece here from the templates, go into other, go to Cornlathe template. This one, the other one is just German, I guess. And I'll call this offset group test. I'll drag this down to the right mouse button and get rid of all of that stuff and create a new piece. So this will be a shallow 4-inch curve. I want to be on the outside of it in both of these spots. So my axis is on the outside of this curve. Right now the thickness is 0.1. I could change that to 0.2. Doesn't make a big difference. It just helps with visualization. So offset group is a little different, but it's a way of getting rosettes spread around a curve the way pattern point can do it. So you have to drag that offset group down to the axis, and you see a pink line and a pink vertical line, and this shows you the distance between the center of the piece and the offset here. To get a rosette, you drag the rosette point down on top of that, and you have to take that and drop it exactly on the offset group marker labeled 0. Then you get the 0A, and you can move that a little like that, and you could drop another rosette on there, and you move that on top of that, and you get 0B, like that. Now this is kind of confused because there's so many cut points there, but I'll tidy that up. So this has a depth of 0.05, that's fine. It's a rocking thing. The sine 8, 8 repeats on the sine pattern, and that's fine. Now what I want is this repeat. Say I only want 3 of those. Once this is made as a group, you can move the whole works over like that. And I can't say I've used this very much, but that's how you get a rosette planted on that. The sine 8, so to change the numbers was this very first line, down to 3. If I wanted just 2 there, then that would give me 2 or 4. Back to 3. And once again, if you want, you can change the number of repeats of that sine down to 6, for example. That simplifies things. That was the bottom sine. Put that one down to 6, and then you get a symmetrical pattern. And you could change sine to, say, big small. Let's see what that does. And change this other one from sine to big small. And that makes something interesting. I don't know how that'll cut out, probably not very well. I'll change my cutter to a 60-degree point. I'll leave this as a horizontal cutter frame for now. And let's render that and see what happens. Sometimes I find these get a little muddy looking when you're trying to plan them because it's trying to give you the surface. Let's take the lines out of there, and you can get the idea of the way that one would cut out. So that's how you get a rosette onto a curve. This one doesn't have an optimize button, so far as I know. the way that pattern point is. But once again, you'd have to be careful about your selection of rosette. And the same as pattern point, the pink line here gives you the information about how far down things are, so distance to the top. This one here, in this case, just about 0.9 inches. And if you look at the grid, you can see that's just about 0.9. So that's the way that works for rosette point. So that completes my exploration of the Cornlathe cut point palette. I hope it's proved useful for you. Thank you for watching.